8 acids and bases. So titration, I'll discuss uh, some important concepts of the titration. We'll do some questions and then we can move to next unit, unit 5. As I said earlier, unit 5, 6, 7, they will move very fast because their number of topics are less as compared to 3, 2, 1, right? Okay, so starting with the redox reactions. So first we need to understand the meaning of reduction and oxidation. These are two half reactions. One reaction is called as reduction, other is called as oxidation. So I'll make you understand the meaning of reduction and oxidation. Children, what you are learning today, please write down in your notes that when I start unit 9, you will come prepared with this part again. I'm not going to repeat it at that time. Okay, so I'll ask you to review this part, this particular video. So what is reduction? Reduction, the basic definition is gain of electrons. Gain of electrons. Electrons I will be writing like this and I will be placing S here to make it electrons. 1, 2, 3, 4. This is the basic definition. And what is oxidation? Oxidation is, yes, loss of electrons. So some people, they give you different types of shortcut to memorize it, like reduction, gain of electrons, oxidation, loss of electrons. So they say Leo says girl. But after doing this oxidation reduction with me and doing plenty of questions, I don't think you'll be using it anywhere. Leo means loss of electron is oxidation, gain of electron is reduction. There are many more, but I don't think there is one more like oil rig. So teachers are using these also. O means oxidation is loss of electron. Reduction is gain of electrons. Right? Okay. Can you change your name, Sushant? Okay, now let's see. I'm going to give you some examples and then we'll start understanding oxidation reductions. For example, I'm taking sodium. To this, I'm adding oxygen gas. So what is this reaction called as? This is a reaction which I'm doing. What is the name of this reaction? Combustion, right? Combustion in the presence of air. And the product is Na2O. If you look at this sodium, there is no charge, zero. If you look at this oxygen, there is zero charge. Pure element, these are pure elements. So they have zero charges on them. But if you look at this ionic compound, and if I ask you to predict the charge on sodium in this compound using the periodic table, so what is the charge on sodium? Take out your periodic table, children. Periodic table should be on your study table, not a small simple one on the table. Sodium is +1 and oxygen is -2. So sodium is going from 0 to +1. So what sodium is doing? Losing electrons, gaining electrons. Sodium. Sodium is losing electrons. So can I say sodium is undergoing oxidation? Sodium is undergoing oxidation. And what about this oxygen? What oxygen is undergoing? Oxygen is gaining 2 electrons, right? So can I say it's reduction? Now one is losing, other one is gaining. So we can call this reaction as a redox reaction. So this reaction is redox, reduction, oxidation. Reduction, oxidation, Both the reactions will take place simultaneously. You cannot say that, okay, there is reduction but no oxidation. This will never happen. If there is reduction, there is oxidation also. Electrons will never come in the solution or in the air. Electrons are given by one species and immediately they are taken by another species. If there is somebody who can oxidize, then we need somebody who can reduce. Only then the things can happen. One will get oxidized, other will get reduced. Like here, sodium is getting oxidized and oxygen is getting reduced. Say redox reaction, and they both the reaction they take place simultaneously, means together. There is no existence of reduction without oxidation, and there is no existence of oxidation without reduction. Electrons will never be in the solution or in the air. They are always within the atom, within the ion, right? So that's the meaning of oxidation reduction. Now, how to identify oxidation reduction? So you can easily do it using the periodic table, but all the time it's not uh, easy. So we have some oxidation number rules. So I'm going to teach you the oxidation number rules. Oxidation number. So what is oxidation number? Which I will be writing as ON, right? So what is oxidation number? Like for example, you said sodium is 1 plus. So this is the oxidation number of sodium, the charge on it, charge on single atom when all other atoms are removed. Like for example, if I give you CO2 and I remove these two oxygens, remove them. You know each oxygen is minus 2. Two oxygens means there are two oxygens. It means minus 4. So what is the charge left on carbon? Plus 4. So this is how we are going to define the oxidation number. It is the charge left per atom. The charge on the atom or charge per atom. Single atom. In a molecule, ionic compound, whatever, right? It is the charge per atom when rest other atoms are removed. Is it okay? So please don't get confused with the oxidation number definition, because many times children they start giving me the oxidation number of a group of atoms. No, it's per atom. So let's see the rules. So rule number 1 is for pure elements. Pure elements means they have not combined with anything else. Pure element made up of only one type of atoms like N2. N2 gas, O2 gas, O3, Fe atoms, Fe metal, potassium, sodium, all these are pure elements. F2, Cl2, I2, Br2 diatomic, these diatomic gases. Remember this is diatomic gas, this 1, 2, 3, 4, one more, H2. These are diatomic gases. This is solid. This we did in unit 3. This is liquid. We discussed everything, why it is liquid. This one is solid, this one is liquid, and these two are gases. IMF. So in all these cases, the oxidation number is 0. Is it okay? So generally, we can write in brief like this. Rule number 1, free elements. You know the meaning of free elements now? Three elements means pure elemental form, not combined with any other element. Oxidation number is 0. Is it okay? Rule number 1 is clear. Write it like this, the way I have written on the side. It's in very short and after understanding. And write the examples. N2O2, O3, ozone gas. They all have P4. P4 is also the pure elemental form. P4, S8, O2. Write down these examples. They have 0 oxidation numbers, right? Rule number 2, if you have a monoatomic ion means Na plus. If I give you Na plus, what's the oxidation number here? 1 plus. The charge. If I give you Fe3 plus, what's the oxidation number? 3 plus. If I give you N3 minus, what's the oxidation number? 3 minus. So write down rule number 2. Rule number 2 is monoatomic ions. Monoatomic. It should not be polyatomic. Okay. Single atom because oxidation number is per atom. Monoatomic ions. Oxidation number is the charge on the atom. Charge on the atom. Whatever charge. So oxidation numbers can be 0, children. Oxidation number can be 0 like rule number 1. Oxidation number can be plus. Oxidation number can be minus. And oxidation number can be in fractions also. I show you some examples. It can be in fractions also. Okay. This is rule number 2. Rule number 3. Rule number 3 is for oxygen. Oxygen, you know. Rule number 3 is for oxygen. I'm writing here oxygen. If your compound is an oxide, sodium oxide, magnesium oxide, then the oxidation number is -2, which you already know from the periodic table, that oxygen can gain only 2 more electrons, right? Oxide we know very well. But there is one more species of oxygen. Actually, there are 2 more, but for AP we need only 1 more. That is peroxide. You heard about it? Hydrogen peroxide. This is a polyatomic ion, O2, 2 minus. This peroxide, children. O2, 2 minus. Shrihan, O2, 2 minus. Peroxide. Now, what is the oxidation number of this peroxide? The oxygen in this peroxide? Yes, children. Oxidation number is the charge per atom. There are 2 oxygens with 2 minus. So what's the oxidation number of each oxygen? Like oxide, it is always -2, but peroxide it is no, 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 no. Oxide is -2, peroxide is -1. Yes, but it's a peroxide. The name will be peroxide. Then there is one more which AP is not talking about, but you know about this oxide. You know, you play with crackers, firecrackers, fireworks. You can see beautiful colors. They are small explosives, not very big. So generally we use them and they give you beautiful colored light. So what are they? They are superoxides. Superoxides are very unstable. They are explosive. Okay, and they are O2 1 minus. This is superoxide. Though AP is not asking about it. Is it okay, children? Superoxide. So what's the oxidation number of oxygen in superoxide? Oxidation number of each oxygen in superoxide. Answer please. Ashita, you're there? No, 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 no. Why? Yes, Saranya, you're right. Ashita, please answer here. Ashita. Yeah, keep answering. Okay, this is, don't worry, you missed some classes, but it's entirely new topic today. You can learn, okay? So pay attention. Yes, Lasya. That's what I was trying to tell you from starting only, that it is the charge per atom, Dhruv. Charge per atom. How many atoms are here? Two. So what is the charge per atom? Minus 2 over 1. Oh, sorry, what I said. Minus 1 over 2, right? Minus 1 is the charge. Number of atoms are 2. So what's the oxidation number of this oxygen? Minus 0.5. Minus 1 by 2. And I told you that it can be in fractions. So those who were answering wrong, please take care of this. Oxide, peroxide, superoxide. Superoxide, we need not to worry. If you cannot retain it, don't worry. It's just for knowledge that you are using firework, firecrackers. What is there inside it? Superoxides. Superoxides of transition metals, even of sodium also. And they explode. When they explode, they give lights because of the electronic transition. Light is colorful light, color, all the colors, blue, red, green. Whenever you are talking about the colors, it is due to electronic transition. You know, ultraviolet visible. Ultraviolet visible is electronic transition. Electronic transition means electrons are jumping from low level to high level to low level, like this. Okay, so these are three important rules from this particular slide. Rule number 4 is for hydrogen. Rule number 4 is for hydrogen. Hydrogen can be, I'm writing the rule here on this side. Although the rule is written here also, but try to understand with where I'm writing. Hydrogen, when it is bonded with metals, hydrogen is bonded with metals, then metals are always positively charged. They can only lose electrons. They cannot gain electrons. They never acquire a negative charge. All these things we have done with metals, right? So metals, they always lose electrons. So metals are positively charged. So what is hydrogen? Minus 1. Hydrogen with metals is minus 1. Always. Ma- Hydrogen can gain only one electron. You know that hydrogen electron configuration is? Yes, children. What's the configuration of hydrogen atom? 1s1. So it can gain one electron to become H minus, and then it is 1s2. Just like helium. Happy, stable, right? But this can happen only with metals. When hydrogen is with metals, metals will lose, hydrogen will gain, right? This is reduction. Now, hydrogen can also undergo oxidation like this. This is hydrogen, this one, and it will become H plus. Now there is no electron. So it can exist in this form also. But this can happen when hydrogen is bonded to non-metals. Non-metals. Then hydrogen oxidation number is 1 plus. Here it is minus 1. So here hydrogen is like H minus. Here hydrogen is like H plus. This H plus is also called as acid. It's called as acid proton. So please write down that this is your proton. Why it is called as proton? Any one of you? Why we are calling H plus as proton? Can you tell me what is inside this hydrogen? You know, hydrogen, there is a nucleus. This is hydrogen atom. There is one electron and one proton. How many neutrons inside the nucleus? Number of neutrons? Zero neutrons. So in hydrogen, there is one electron, one proton, and zero neutron. We're okay with this? Now you remove this one electron. Remove this. Then what is left? Just the nucleus. The shell is out. There is no shell, just the nucleus. What is there inside the nucleus? One proton and zero neutron. So what is H plus? It's just a proton. H plus is a proton. So we call it as proton. In unit 8, I will always going to call it as proton. Proton acceptor, proton donor, then that proton is H plus. That proton is not a proton of any other element, it is the proton of H plus. So proton acceptors are bases, proton donors are acid. Whoever can give H plus in water is an acid. So this proton word is very important for you. Try to retain it. So rule number 4 is clear, children? This rule number 4. Any questions? Okay. Up to rule number 4, everything is specific about a particular element, ion, free element like this. Now rule number 5 is, rule number 5, I'm writing here, sorry. Rule number 5. Rule number 5 is for fluorine, alkali metals, alkali metals, and for alkaline earth metals, alkaline earth metals. Alkali metals are group number 1. Group number 1 elements are always, group number 1 elements are always plus 1. Always, right? Plus 1, Sanjana. And alkaline earth metals are group number 2. And group number 2 are always plus 2. Arana, what is 8? Oh, noble gases, their oxidation number is 0. They are pure elements, not 8. Noble gases, oh, okay. Noble gases, they fall in these free elements. Rule number 1. They have 0 oxidation number. And fluorine, what's the oxidation number of fluorine? Fluorine can always gain only 1 electron. So minus 1, Sanjana, take care of the charges. Oxidation number is minus 1. This is rule number 5, children. Rule number 5. Now let's see rule number 6, the last rule. Rule number 1 is for free elements, 0. Rule number 2 is monoatomic ions, whatever charge is the oxidation number. Rule number 3 is for oxygen. Oxide, peroxide, superoxide. If it is oxide, which is generally oxygen is oxide in 99% compounds. If it is oxide, minus 2. If it is peroxide, minus 1. If it is superoxide, minus 1 over 2. Superoxide, you need not to worry. Rule number 4 is for hydrogen. If it is bonded to metal, minus 1. If it is bonded to non-metal, plus 1. Rule number 5 is alkali metals, alkaline earth metals. They have fixed oxidation numbers, and fluorine is also fixed. Chlorine, bromine, iodine, they are not fixed. They can show you variable. Now, rule number 6, calculate for others. Rule number six is the one which are not mentioned here. Calculate for them. How to calculate? You are going to use this rule that sum of all oxidation numbers is equal to the charge on that species or 0. If no charge, then put 0. If it is an polyatomic ion, some ion with some charge, then put it equal to that charge. So now I'm going to explain all these rules again with the help of examples. So let's do rule number 6. Like for example, if I give you NO3 minus, is this nitrogen mentioned anywhere in the rules? 1 to 5? No, there is no rule for nitrogen. Nitrogen can show you variable oxidation number. So you're going to assume this nitrogen has X. Do you know the rule for oxygen? As I said, in all polyatomic ions, oxygen is oxide. So there are 3 oxygens, right? Each oxygen is -2 is equal. Do we have any charge here? Yes, -1. So what is X here, children? What's the oxidation number of nitrogen? Algebra? Do algebra here. +5, +5, right? Now let's see this molecule, ion, SO4 2 minus. The way I worked here, can you work here? Get the oxidation number of sulfur, knowing that oxygen is -2. So you're going to assume, yes, Arjun, very good. Very good, Arjun. See like this, +6. So please write down these rules and let's practice very fast one unique example. Okay. So all of you are answering now. N2, oxidation number. Rule number 1, pure element, free element. What's the oxidation number of N2? 0. Very good, Ashita. NH3. Rule number 4, hydrogen is with non-metal. So hydrogen is +1. So nitrogen I want to calculate. So X plus 3 times +1. Is there any charge on this? No. So what's the oxidation number of nitrogen here? Is -3. Srayu, you're not answering? Srayu, you're there? Yeah, then answer here also, dear. No problem. You can answer late. Okay. You can answer late. You can just write down that, okay, I put the number. When you answer late, then you put the number in front of your answer. I just want to be sure that you are listening and you are doing well. Third, NO. What's the oxidation number of nitrogen here? No, Dhruv. Oxygen is -2. So X -2 equal to 0. So nitrogen is +2 in third. Fourth, what's the oxidation number of nitrogen here? You know that nitrogen, you can assume it as X, 2 times -2. Why? Shrihan? Do mathematics here. Assume x, okay? There's no harm in doing like this. Children are very hesitant. They want to calculate straight away. You can do that also. See here. This is minus 4. So this has to be plus 4. See here. This is minus 2. So this has to be plus 2. So you can do directly also, but in the exam, go with the safest route. Okay. So it is plus 4. Check this one. NO2 minus. This one. Nitrogen is X. 2 times minus 2 is minus 1. So what is X here? What is the oxidation number of nitrogen in fifth? Plus 3. Check this one. N2O. Check the oxidation number of nitrogen. So the one which I'm not going to show you stable oxidation number, for that rule number 6 is applied. Like you can see that nitrogen is showing you so many, not a fixed oxidation number. So most of the elements, they show many oxidation numbers, except the one which I mentioned in the rules, like hydrogen, oxygen, first group, second group, and fluorine. They show fixed oxidation numbers. Rest all will show you variable oxidation number and you have to calculate. So what is here, children? Nitrogen. Saranya is writing. This time I'm going to say 2x, right? Because there are two nitrogens. Plus 1 time minus 2. So what is the oxidation number of each nitrogen? Each. Oxidation number is per atom. Is plus 1. Yes. Yes, good. Okay. One more. NO3 minus, though we have done it already. NO3 minus. Is plus 5. Now, see these examples 1 to 5. Can you tell me the range of oxidation numbers here? The range. The lowest oxidation number to the highest oxidation number. Lowest means the most negative. What is the range? Yeah, minus 3 to plus 5. Do you know the electron configuration of nitrogen? Helium 2s2 2p3. So how many maximum electrons nitrogen can gain? 3. See, it can gain 3 electrons and it can become N3 minus. Correct? So the lowest oxidation number for nitrogen is minus 3. Like for oxygen is minus 2. It cannot have minus 4. It cannot have minus 5. You're understanding this, children? So maximum nitrogen can gain only 3 electrons because of its electron configuration. 3 electrons. You know the reason why? Because after gaining 3 electrons, it will become 2p6. What are you writing, Shirhan? 2p6, right? But what can be the maximum oxidation number? How many electrons maximum it can lose? 5 only. That's the reason the range is from minus 3 to plus 5. Shrihan, don't chat with anybody else, okay? Pay attention here. Oh, okay. So minus 3 to plus 5 is the range of oxidation number. Now answer this question. It's a smart question. Can we have NO4 minus? Check the oxidation number of nitrogen here. X plus 4 times minus 2 is minus 1. So X is plus 7. So do you think this particular species is feasible? No. Yes. because the maximum oxidation number nitrogen can have is +5 because it has only 5 valence electrons. So if it loses all 5, the maximum is +5. So that's how you will never see this ion. This polyatomic ion does not exist. So we have a list of polyatomic ions. So you must be wondering that why we have a particular list. Why can't we have random polyatomic ions? No, we cannot, because these ions are formed by taking care of the valence electrons, by using the valence electrons. So valence electrons are going to decide which polyatomic ion will form and which will not form, right? So this is a very important question we have just done. So are we clear? You have written all the rules. One last example. So now let's clear everything. Work out the oxidation number of chromium in Cr2O7 2 minus. Chromium oxidation number. You are going to do this question. There are 2 chromiums. So please understand I'm asking per chromium atom. So you can assume it as 2x. There are 7 oxygens. The charge is, now Shrihan, check your answer. Shrihan, can you check your mathematics? Because the answer is +6. Anyone has any problem in understanding how to calculate oxidation numbers by using these rules? Okay. I'm going to show you some reactions, half reactions, and you're going to identify them as oxidation or reduction. Reduction is gain of electrons. Now I'm giving you one more definition of reduction. So what is reduction? Till now, what I said, what is reduction? Is gain of electrons, right? But when the species, when the atom is gaining electrons, it's acquiring a negative charge, correct? A negative charge means low oxidation number. So reduction is also decrease in oxidation number. Please write on this. Decrease in oxidation number means oxidation number is becoming more negative. This definition is going to help you a lot. Oxidation, what is oxidation? Yes, loss of electrons. So during oxidation, when electrons are coming out of the atom, the positive charge is increasing. So what happens to the oxidation number? Increase in oxidation number. Increase in oxidation number. Write down these two definitions again. And now I will give you some half reactions. Half reaction is either it is oxidation or reduction. We have to identify whether this reaction is oxidation or reduction. Ready? Ready for question, children? Can I erase this? Okay. So now let's do it. Very important thing we are doing right now. The unit 9 is based on electrochemistry, is based on oxidation reduction. When we are going to do unit 9 around end of the March, end of the Feb, sorry, around end of the Feb or starting of the March, at that time, come prepared, review this particular video. Okay. NaH, I'm giving you only half reactions, so don't worry about balancing. NaH giving you H2 gas. What is it? Oxidation reduction. Of course, Na is also there, but I'm just giving you half reaction. So Na is metal. What's the oxidation number of hydrogen here? Rule number 4. Remember rule number 4? Hydrogen when combined with metal. Yeah, because sodium is going to be +1. Sodium is always +1. So hydrogen is -1. Very good. And what's the oxidation number of hydrogen here? 0. Sanjana, 0. Pure element. Rule number 1. Pure element. Rule number 1. So that's why I asked you to write down the rules when I was writing on the side. Rule number 1, pure elements, 0 oxidation number. Rule number 2, monoatomic ions, the charge on the ion. Rule number 3, oxygen, it can be -2 for oxide, -1 for peroxide. Rule number 4, that is for hydrogen, with metal, -1, with non-metal, +1. Like this, okay? So what is this? Is it losing electrons or gaining electrons? Going from -1 to 0 is an increase in positive oxidation number or decrease? -1 to 0. Is it increase in oxidation number? Yes, Arana, it is increase. So each hydrogen is losing electrons. Am I right? Hydrogens are losing electrons. So how many electrons are lost by this hydrogen? One hydrogen. H -1 to H0. How many electrons? -1 to 0. One electron. I will write here, right? But how many hydrogens are here? There are two hydrogens. So how many electrons are coming out? Two electrons, right? Two electrons will come out. And this reaction is oxidation reduction. Sorry. This reaction is oxidation reduction. It is oxidation. I'm taking you now on the whiteboard because here we have some problem when we try to erase something. Now more examples. SO2 to H2S. Identify oxidation or reduction. Check the oxidation number of this sulfur. How much? Oxidation number of sulfur. Use rule number 6, sum of all oxidation number. Oh no. Arhana is right again. Is +4. How you did it, Dhruv and Lasya? You're going to assume it as X. There are two oxygens. So -2. Each oxygen is -2. The total charge on this species is 0. Rule number 6. Sum of all oxidation number here is 0. So what is X? Is +4. Dhruv and Lasya, okay? Now check this H2S. What's the oxidation number of sulfur? No, wait. It's H2S. It's not free hydrogen gas. Shrihan. It's not free H2. It is combined with sulfur. It's a formula of hydrogen sulfide. In fact, the name is dihydrogen sulfide. You are going to assume sulfur as X. Each hydrogen is +1 because they have combined with non-metal. Rule number 4. Then Plus 1 is multiplied by 2, right? There are 2 hydrogens. Each hydrogen is plus 1. This is how you have to work. Yeah, rule number 4. Shrihan, check rule number 4. Is equal to 0. So what is x? Is minus 2. Yes, so going from plus 4 to minus 2 is reduction. Can you tell me how many electrons sulfur is gaining? Plus 4 to minus 2. No, no, no. Shrihan, your answers, you have to think, do mathematics before you answer anything. Are you going from 0 to minus 2? You're going from plus 4 to minus 2. So how many electrons? 6 electrons, isn't it? Minus 6 plus 4 is minus 2. Do mathematics. So don't answer randomly, okay? Do some mathematics before you answer anything. Is it clear, children? Is gaining 6 electrons. Now you can see the charge on both the sides. This is plus 4, right? Here. 6 minus 6 plus 4 is, the sulfur is now minus 2. That's how it is going to work. Okay. So it's reduction. Ready for one more? Try to answer this time very accurately. This will be the last example we are doing. NH3 to NO3 minus. What is it? Oxidation, reduction. So check the oxidation number of nitrogen here. Use rule number 4, Shrihan. Rule number 4, hydrogen when bonded to non-metal, its oxidation number is always plus 1. So X plus, there are 3 plus 1, right? Is equal to, is there any charge? 0. So X is minus 3. So nitrogen here is minus 3. This is simple algebra equation. Get the oxidation number of nitrogen here. Is plus 5. Who is this? Arhana. Very fast. Very good. You assume it as X. There are 3 oxygens. Each oxygen is minus 2. Is minus 1. So X is plus 5. Algebra. Going from minus 3 to plus 5. Oxidation, reduction. Is oxidation. What are you writing, Shrihan? You are writing minus 2 for the first one? This one? No, I didn't get it. From where you are getting minus 1? Oxygen is minus 1 or minus 2? Shrihan. For the second one, this is the equation. Check the equation, what you have written and what I have written. Correct your equation. So minus 3 to plus 5 is oxidation. Can you tell me how many electrons are given out? Oxidation means electrons are coming out. How many? Minus 3 to plus 5. I have to write electrons on this side. It is 8 electrons, right? That's why the oxidation number is changing by 8. See, the total change is 8. Minus 3 to 0, 3 electrons. 0 to plus 5, 5 electrons. So total electrons are 8. Is it right? So children, are you comfortable with these oxidation numbers and identification of oxidation and reduction reactions? One last example. Cr2 O7 2 minus 2 CrO4 2 minus. What is it? Which one, Saranya? The previous one? Okay, by the time you do this, I think Saranya is asking previous one, that NH3 to NO 3 minus. This one, Saranya. Okay, so what is the oxidation number of nitrogen here? Minus 3. What is here? Plus 5. What is this? Increase in oxidation number. Minus 3 means plenty of electrons. Plus 5 means electrons have gone out. Less electrons. So how many electrons is losing? It's a loss of electron. Remember we decided 8 electrons. There's a loss of electrons. Increase in oxidation number is loss of electron, which is oxidation. No problem. By the time did you decide this equation, children? The above one. Work out the oxidation number of chromium. So I think in this plus 6. In this plus 6. Very good. So is it a oxidation reduction? No, nothing. It's neither oxidation nor reduction. It's not the part of redox reaction. If something like this is given to you, then we say it's not a redox reaction. So write down this statement. No change, because they can give you this question. They will give you 3, 4 equations and they will ask you which equation is redox reaction, which equation is not a redox reaction. This can be a multiple choice question. No change in oxidation number. Not a redox reaction. You just check the oxidation number. Not a redox reaction. Change in oxidation number. If during the reaction there is change in oxidation number, then it's a redox reaction. Redox reaction. So this can be one of the questions. Identify whether the given reaction is a redox reaction or is not a redox reaction. So I'm giving you 2 reactions here. You have to tell me which reaction is redox and which reaction is not a redox reaction. So we are doing one reaction here, children. NaOH reacting with HCl, giving you NaCl and H2O. Another reaction is H2 reacting with O2, giving you water. This is combustion. Combustion of hydrogen gas, right? Balance the equation. Identify which one is redox and which one is not redox. So let's start. Check the change in oxidation number. What's the oxidation number of sodium here? Rule number 5. Alkali metals are always. Alkali metals are always. Check the rule number 5, children. Yes, it is plus 1. And what is sodium here in this compound? Plus 1. Is there any change in oxidation number of sodium? No. What's the oxidation number of hydrogen here? Plus 1, because it has combined with non-metal. It's acidic hydrogen, is proton. And what's the oxidation number of hydrogen here? Again, it has combined with a non-metal oxygen. So what is here? Again, plus 1. Is there any change in oxidation number of hydrogen? No. Now let's check for this hydrogen, this chlorine. If this is +1, then what is chlorine? You can calculate. Rule number 6, -1. If this is +1, what is chlorine? -1. Is there any change in oxidation number of chlorine? No. What's the oxidation number of oxygen here in water? -2. So what can be the here? Like this oxygen is -2 and this hydrogen is +1. Is there any change in oxidation number during this reaction? There is no change in oxidation numbers. And this reaction is called as neutralization reaction, acid-base reaction, remember? Isn't this is sodium hydroxide is a strong base, hydrochloric acid is a strong acid. So it's a neutralization reaction. Neutralization reactions are not redox reactions, are not redox at all. Okay. Similarly, double displacement. Remember we did double displacement, precipitate formation, net ionic equation, double displacement reactions. They are also not redox. You can check, take any example of double displacement and you can check their oxidation numbers. There is no change in oxidation number. Okay, so please write down these two statements, including this one. Now check here, the second one. This one. So what's the oxidation number of hydrogen here? Rule number 1, pure element, free elements, 0. What's the oxidation number of oxygen here? 0. What's the oxidation number of hydrogen here in the molecule, in this molecule? +1. What's the oxidation number of oxygen here? Oxygen. -2. So, is it a redox reaction? Is there any change in oxidation number? So, going from H2 to H2O, what is it? Increase or decrease? Check, I'm going from hydrogen gas, 0 to +1. Oxidation, yes, increase in oxidation number. This is oxidation, children. Hydrogen is oxidized, yes, Arjun. H2 gas is oxidized to water. And O2 to O2 minus, reduction, reduction. So when hydrogen is getting oxidized, where are the electrons going? When hydrogen is getting oxidized, where the electrons will go? Hydrogen is losing 2 electrons. There are 4 hydrogens, so 4 electrons are given off. So hydrogen is losing electrons. So where are these electrons going? They are not coming in the solution. They are not going in the air. Where are they going? They are gained by oxygen. Very good, Dhruv. So hydrogen gas is oxidized and helping in the reduction of O2. Hydrogen is oxidized and helping in the reduction of O2. So oxidized species, the one which is undergoing oxidation, oxidized, they act as reducing agent. So they are helping in reduction. Agent means helping. So whatever is getting oxidized is a reducing agent. And oxygen is getting reduced, is gaining electrons. And because it is gaining electrons, that's why we can say it is helping. in the oxidation of H2. Because if oxygen doesn't gain electron, then H2 will not get oxidized. H2 is getting oxidized because oxygen is gaining. So can I say oxygen is helping in the reduction of H2 or in the oxidation of H2? Sorry, correction. Oxygen is helping in the oxidation of H2. So whatever is getting reduced, oxygen is getting reduced here, is the oxidizing agent. Can I say this, children? So whoever is getting oxidized is helping in the reduction. So it's the reducing agent. Whoever is getting reduced is helping in the oxidation of other species. So it's the oxidizing agent. But you children are very lucky. AP will not be talking about these two particular words. Earlier we used to teach. So don't worry. I have given you these words because when you read the book, you can see there. And they are important terms, but somehow AP has omitted them. So AP will talk only about oxidized and reduced. Okay. So now I'm moving on to the next topic, that is balancing of redox reactions. We have understood the meaning of oxidation, reduction. Now we are going to do balancing of redox reaction. There are two methods, and okay, one second. Fine. So you will write down the rules. Can I go on the whiteboard? I'll give you rules from my side. One is half reaction method. What is half reaction here? Half reaction method is very important. It is the one which we are going to use in Unit 9. Half reaction means oxidation reaction treated separately, reduction reaction treated separately. So the rule number 1, I'm going to balance this equation. Cr2O7 2 minus 2 Cr3 plus, this is in the presence of Fe2 plus, giving you Fe3 plus. So it's a net ionic equation. Other ions are not visible because they are spectators. They are the only one which are undergoing a change. So in net ionic equation, we need to balance it. Okay. This balancing is not done just by looking at the numbers. Okay, you can see that oxygen is not there on the right side. We need oxygen also. So we have to follow certain rules here. So when I'm balancing this equation, when I want to balance this equation, I will take care of two factors. One, two factors with certain rules. These two factors are, I will balance the charge. Very important. Remember, I told you earlier that when you make a solution, you don't have extra charges. You have to balance the charge on the left side and to the right side. Balance charges. That you have to do. Second, balance atoms. Whenever you are balancing, it's not for redox, it's everywhere. Whenever you are talking about a balanced equation should have balanced charges on the left side -2, so on the right side also -2, and they should have balanced atoms. That equation will be called as balanced equation. So please write down. Now you are big AP children, okay? So now you are not just balancing by just looking at the atoms and balancing. You have to take care of the charges also. A balanced equation means the charges and atoms must be balanced. So always take care of this. Now I'm going to tell you the rules. How to do this? We have to follow certain rules and you are not going to break them. So follow the rules. What are the rules? First rule. So I'll be writing in brief. Write two half reactions. Let's do that. Let's apply rule number 1. Now don't worry about oxidation reduction. This method, half reaction method, is for children who are unable to understand how to calculate oxidation numbers. So I'm saying don't worry about anything. Just follow the rule. Write two half reactions. So one half reaction you can identify like this. Am I right? Fe2 plus to Fe3 plus. So I'm writing Fe2 plus to Fe3 plus. And second is this one. Check the species. They will tell you that, okay, I'm one half reaction, I'm another half reaction. The species are telling you. So just work with the species and identify two half reactions. These are two half reaction. Rule number 1 is done. Rule number 2, balance. For the balance, I will be writing B only. It will come again and again. B means balance. So balance two half reactions separately. Now I will start balancing them. Balance means I will balance the atoms, I will balance the charges also. That's what I told you. When you're balancing, you have to balance the atoms, you have to balance the charges. But we are going to follow a particular sequence for doing that. What is the sequence? In this rule number 2, first is, see, I'm writing A here. Balance atoms other than hydrogen and oxygen. You can do that. Please write down these rules the way I'm writing. B, B means balance. Can we apply this rule on these two equations? Balance this Fe. Is it balanced? Balance this Fe and Fe. Are they balanced? Yes, they are balanced. Do I need to do something here? Yes, children. Do we need to do something? I hope you're following the rules. No, no, I didn't say get rid of anything, Shrihan. Don't apply your rules. Follow my rules. Okay, I didn't say get rid of anything. I'm asking you to balance atoms other than hydrogen, oxygen. So don't touch oxygen. Don't do anything. So what is the other atom? Chromium. Balance it. Put two chromiums here. Yes, for the chromium. Yes, Saranya. Right? So Shihan, we have to follow the rules. Don't touch oxygen and hydrogen here. Rule number 3. Now we are on rule number 3. Sorry, not 3. Rule number B. We are on rule number 2. This is the B part. Now again balance. Now this time balance oxygen by adding water. So do I need to do anything in the first equation here? In this equation, do I need to do anything for oxygen? No. So just ignore. But I have to balance oxygen here. So how many water molecules should I add on which side? Yes, children? There are 7 oxygens on this side. So I should add 7 water on the right side. Arhana, Ashita, yeah, Sanjana, answers are not coming. I hope you're understanding everything. Are you okay with this? Please confirm. Dhruv. Okay, because this equation I'm doing very slowly. But after that, I'll give you more equation and we go very fast. Okay. Now, C rule. C. Again, balance. This time, balance hydrogen. Hydrogen by adding H plus. So can you see I'm balancing atoms? Balance hydrogen here. There is no hydrogen in the first equation, right? This equation, no hydrogen. Ignore. This equation has how many hydrogens here on this side? 14. So what should I do? I should add 14H plus on this side. Agreed? This is C, A, B, C. Now D. If you see, your chromiums are balanced, your oxygens are balanced, and your hydrogens are balanced. All atoms are balanced. So balancing of atoms are done. But as I said, you have to balance the charges also. So the next is balance charges. But how to balance charges? By adding electrons. By adding electrons. Okay, let's try to understand what this rule says. So work here with me. What is the charge on this side? What is the charge on this side? Plus 2. What is the charge on this side? Plus 3. Plus 2 plus 3, I have to make them equal. Oh, sorry. I have to make them equal. So what should I do? I will add electrons on which side? Where the positive charge is more. I'll add 1 electron here. Now what is the charge on this side? Check. Plus 3 minus 1. Plus 3 minus 1 is plus 2 equal. Now can you identify what is first reaction? Oxidation, reduction. What is first reaction, children? This one. Check. This Fe2 plus is losing or gaining? Is getting oxidized or reduced? Is going from 2 plus to 3 plus. Is going from 2 plus to 3 plus through increase in oxidation number, is losing electrons. This is loss of electron. It's oxidation, right? Okay, and now balance the second one. After balancing the charges of the first one, you can see the electrons are on the product side. If electrons are on the product side, oxidation is loss of electron. Now let's work for the charges in the second one. So we are going to check the charge here. What's the total charge here? Plus 14. See this 14H plus. And this is 2 minus. So how much is total here? Plus 12. Total is plus 12, right? Okay. When you're talking about charges, though, put plus and minus. Now here, what's the total charge? 2 times plus 3. plus 6, and this one is 0. Now I have to make this plus 12 equal to plus 6. Now you can add only electrons, nothing else you can do. So how many electrons you should add on which side? How many electrons we should add so that plus 12 can become plus 6? You add 6 electrons on this side, 6 electrons. So you are adding electrons on the reactant side, reactant. So it's gain of electrons. This is loss of electron because electron is on the product side. And this is gain of electron because electron is on the reactant side. Are we clear? So we have balanced the half reactions. I balance the atoms. A, B, C, atoms are balanced. D, charges are balanced. Now these half reactions are balanced. Now we are going on another rule, rule number 3. Now you have two half reactions which are balanced. You are going to add them together. Add. Add balanced half reactions or equations, whatever you want to write. But there is a condition here. After equalizing the number of electrons lost or gained. You're understanding what I'm saying? If you look at this equation, remember I told you that one is losing, other one is gaining. But over here, this Fe2 plus is losing only 1 electron. But the second one is asking for 6 electrons. So from where it will get to the rest of the 5 electrons? There is no other reaction going on. So in a redox reaction, the number of electrons lost and gained must be same. And if it is not same, then you have to make it equal. How can I do that? So you are going to use a factor. So write on here also by using a factor, mathematical factor, using any factor, depending upon how you have to balance. Like here, I want 6 electrons. My first equation should give me 6 electrons. So you know what I'm going to do? I multiply my first equation by 6. Can you see 6 electrons now? So multiply the first equation by 6 here in this case. So it depends on equation to equation. But the number of electrons during oxidation and the number of electrons during reduction, they must be equal. So first you equalize them and then you add your half reactions. Now add half reactions. This is one half reaction, this is second half reaction. So when I'm adding them, you can see 6 electrons cancelled. They should always cancel out because electrons are not traveling in the solution. Electrons are within the ions atoms. So what is there now? 6 Fe 2 plus 14 H plus Cr2O7 2 minus giving you 6 Fe 3 plus 2 Cr 3 plus 7 H2O. That's the overall reaction, children. I just added rest of the things. These are the reactants. All of them are here. This is the product. All of them are here. Electrons are missing because they cancelled out. You're understanding this? Now the last rule is check. Check rule, whether you are right or wrong. Check charges on both the sides. Check charges on both sides. Can you check how much is here on this side? Please answer this question. How much is here? It's very important that you should know how to check the charges. 6 times 2 plus 14 times 1 plus 1 time, this is 1. 1 time 2 minus. How much is this total? Is it plus 18? No. Plus 24. Dhruv is saying 24. Yeah. Can you do the same thing here? Can you check the charges here? 6 times plus 3. 2 times plus 3. And water is 7 times 0. So how much is here on this side? Is plus 24. It means my equation is correct. It means I have done the correct balancing. The problem with the rules is you have to follow them exactly the way they are written. And you can see that it's very easy. You're using your brain only when you are checking how many electrons we have to add, only when you are checking the charges. Brain is needed only at that time. Otherwise, it's a brainless method, right? But can you answer this question, children? This equation is in acidic medium or basic medium? All of you, please try to answer. Look at the final equation. You know acidic means? What's the meaning of acidic? Acidic means H plus. H plus. H plus is acid. Basic means OH minus. So this equation is in acidic or basic? It is in acidic condition. You see 14H plus. So when they will give you an equation, they will say balance this equation in acidic condition. But they can also say balance this equation in basic condition. Then what should I do? Follow the same method which I have given up to 5. Then write down one more rule, 6th rule. Yes, Dhruv, definitely. I said I'll give you 3 examples on this method. One is done. We'll do 2 more. Then I'll teach you another method. Okay? We'll do more examples. Don't worry. Rule number 6. If I want to make my equation in basic condition, if they say balance the equation in basic condition, then how you're going to do it? Add OH minus equal to H plus on both sides. On both sides. Don't add it only on one side. If you add it on one side, your equation will become unbalanced. Like how many H plus are here? 14. So how many OH minus should I add, children? 14. So 14 OH minus on this side and 14 OH minus on this side. But this 14 H plus and 14 OH minus will become, you know, H plus and OH minus yeah, combine them, H2O. So this is 14H2O. So now let's write down the changed equation. I'm writing here. the change equation where the H plus and OH minus on one side has become water. H plus is neutralized. There is no H plus now. In place of H plus, there are 14 H2O. 14, right? Cr2O7 2 minus, giving you 6Fe 3 plus 2Cr 3 plus 7H2O plus 14OH minus, right? But water is here on this side and water is also here on this side. It cannot be present on both the sides, so you have to subtract it, right? So this make it 0. This is 0. And how much is this then? 7H2O. 14 minus 7, right? So there are 7H2O on the reactant side. And this is your equation 6Fe 2 plus 7H2O plus Cr2O7 2 minus 6Fe 3 plus 2Cr 3 plus 14OH minus. Now this equation is in basic condition. See, 14OH minus. The equation is in basic condition and you can check the charges. Charges are also perfectly balanced. Everything is balanced, no error. Atoms are balanced, charges are balanced. Equation is balanced if atoms and charges are balanced. But for the redox reaction, we have to follow this complicated method to balance the equation. Simple equations, yes, we can balance. But the equations which are given to you in net ionic equation like this, we need to follow these things. If it's a simple equation, like for example, I'm giving you one simple redox reaction. I don't think you need to balance it by this method. H2 plus O2 giving you H2O. You can see no ions are involved, right? So if I say it's a redox reaction, balance, you need to follow this. Don't follow. Balanced. You can see charges on both the sides, 0. Atoms, 4 hydrogen, 2 oxygen, 4 hydrogen, 2 oxygen. Everything is balanced. So for a normal equation, normal your combustion equations where the elements are combining with oxygen to give oxides, where you are not playing with the charges, you are not uh, doing reaction in a solution, then we don't require this complicated method. Is it okay? Okay, children, you were not answering much because you were trying to understand a new thing. Now we have done it. The new thing is okay with us. I'm going to show you some equations here. You have written the rules. Rules are written. I'm going to show you some equations in the presentation here. So this equation we did. These were the rules, but I've given you in more simplified way. The method which I have used, they have less language. You can easily understand. These are the equations which I want to practice. Which one you want to pick up? Which one? Let's say 1, 2, 3, 4. All of you have written the rules, children? Okay, let's do one thing. Let's go to the whiteboard. And these are the rules, right? So with the snipping tool, I'm going to take the picture of the rules. The equation will not come, children, okay? And here are the rules. You can see the rules now because it will be difficult to write them again. Now let's do some questions very fast. We'll follow the rules, right? If you want some notes like this, that I want this written part as notes. So I can put it like this in the chat. Even with the help of snipping tool, snipping tool, you can do it from your end also. Okay. So let's do equation. Which equation? Equation 1. Do you want to do all equations? Because I have to teach another method also. Something happened to my this. Oh, what I'm sharing? Am I sharing the chat? Yeah. Okay. Question 1. Let's do it. So two half reaction. Rule number 1. Easy to identify. I minus 2 to I3 minus. Whatever you can help me. Second half ClO minus 2 Cl minus. All of you, please pay attention. If you are finding anything difficult, it's a brainless method. Follow the rules. Now balance these two half reactions. So balance the atoms other than hydrogen, oxygen. So what should I do in this equation 1? I'll balance I'm balancing yes, answer. These are the two half reactions. I have to balance iodine first. Yes, 3. Here I have to balance chlorine. They are already balanced, right? So rule number 2, we have started with rule number 2, children. A part is done. Balance atoms other than hydrogen, oxygen. Very good. You can simply write in brief. 3 in front of I minus like this through, okay? If it takes time. Then add, balance what? After doing this, balance what? See the rule number B. Rule number 2, B. Balance oxygen by adding water. So I need to add water. How many? Whatever number of oxygens are here. 1. Here 0. So add 1 water because 1 water will give you 1 oxygen. 1 water. Very good. So we are done with that oxygen also. Now balance hydrogen. I'm asking you to balance this equation in acidic condition. Acidic. So balance hydrogen by adding H plus. So we need 2H plus. Who is this? Throw. Very good. Excellent throw. 2H plus. Now hydrogens are balanced. Now I need to balance. I need to balance. So how much charge here? Here. Answer this. How much is here? And how much is here? See, this 3 is down. Minus 1. So minus 3 here and minus 1 here. So how many electrons should I add on which side? How many electrons should I add on which side? You are going to add 2 electrons on this side. Very good. Perfect. Now you can see charges are same. On the right side, I have added 2 electrons. Now you can identify this reaction. Is it oxidation, reduction? What is it? This one. What is it? Oh, Shrihan. Is it losing electron or gaining electrons? Shrihan, how come it is gaining? No, Saranya. How come it is gaining? If it is gaining, then the electrons should have been on the reactant side. The electrons are on the product side. So it means electrons are coming out. Sanjana, Saranya is losing, right? Please understand. If electrons are on the product side, it means electrons are coming out. It's loss of electron, it's oxidation, right? Check this. Now we have to balance the second one. Balance the charges. Balance charges. How much charge on this side? On the left side, how much charge in the second equation? Plus 2 minus 1. How much? Plus 1. How much on this side? Minus 1. So plus 1 to minus 1 is gain of electrons, right? I have to add electrons. So on which side I should add electrons and how many electrons? On which side I should add electrons and how many electrons? This is plus 1 and this is minus 1. Yes, very good, Dhruv. Children, are you confused with this? That how to add electrons? Okay, good. So Lassia is saying no. So I take those who are not saying anything, it's no from them also, right? Very good, Shrihan. Now check. These two equations are now balanced. Two half reactions are balanced. So we have to jump now on rule number 3. Add these two half reactions, add these two balanced half equations after equalizing the number of electrons lost. Here it is lost. This is oxidation. Here it is gained. This is reduction. Gain means on the reactant side. But these two electrons are same. So nothing to worry. So they can be cancelled out. Add them. So they are same. So you are ready to add them. Add them. 3I minus plus 2H plus ClO minus giving you I3 minus Cl minus and H2O. Now check. Check next rule. Rule number 4. Check charges on both the sides. So children, I want you to participate in this checking because this is where I have seen most of the students are wrong. They are very confused how to check the charges. Check charges. 3 times minus 1 plus 2 times plus 1 plus 1 time minus 1. So how much is this? How much is this charge? Minus 3 plus 2 minus 1 minus 2. Are you calculating charges with me? Do the same thing here. Do the same thing here. This time, any one of you can help me. Yeah, please help me. So this is 1 time minus 1 plus 1 time minus 1. So minus, yeah, plus 0. Yes, throw, very good. Plus 0, water is 0. So minus 2. So charges are same. Equation is balanced. Equation is balanced, right? So we have not done any error. Now what is the condition here? Acidic, basic. Condition is acidic, basic. But if I say balance this equation in acidic condition, then what are you going to do? What are you going to do? You will add 2OH minus on both the sides, right? But this one is H2O. How many H2O? 2 H2O. But this 2 H2O and this 1 H2O, this will become 0 and this is left as 1 H2O. Agreed? So the final equation in basic medium is this. Isabella, you're there? Yes, yes, Lasya. You're right. You're understanding everything? Isabella, you're understanding? It's very important. Unit 9 is based on it. I'm trying my best to be very slow. Ready for one more? One last. Okay. The other two, we are going to use another method. One last. Going to clear it. I hope everybody has written. Cleared? Sarayu, you're understanding, you're not answering any question. So let's do this one. This is the last equation I'm doing. Just show me if you're understanding my method and what I'm teaching you. Please don't break the rules. The rules which I've given you up in the chat. If I can post it again, let me see. Yeah, I can post it again. Yeah, here. Please do not break the rules. Okay. And this method is half reaction method. We are dividing equation into two half reactions. Ready for second equation? Second equation. Children, I just want to tell you one thing that tomorrow there will be no class. It will be 31st night for you and it will be 1st January morning for me. It will be difficult for me to get up because there is a function here late night. So I will not get enough sleep. Okay. So tomorrow's class is cancelled because of the New Year Eve. Okay, ready for this? As2O3. One half equation is this, children? Agreed? One half equation. Another half equation is NO3 minus 2NO. Start balancing. So first rule, balance atoms other than hydrogen and oxygen. So balance arsenic. What should I do? Yes, girls, please keep telling me fast. Put 2 on the stove only all the time. Shrihan, where are you? Shrihan, be faster than throw. Lasya. So 2, place 2 here to balance your arsenic. Balance nitrogens. They're already balanced. They're already balanced. Now, next is balance oxygen. See the next rule. Balance oxygen by adding water. How many oxygens on this side? And how many on this side? No, 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 no. Shriyan, 8. 2 times 4, 8. Here 3, here 8. The difference is 5. So add 5 H2O on this side. Shriyan, you're getting it? Please do not ignore these coefficients which are written in front. Balance oxygen on this side, on these two. There is 1 oxygen here. There are 3 oxygens here. So I need to add, the difference is 2. You can see the difference here. So I need to add 2H2O on the left side, right side, sorry, on the right side. Yes, good, perfect. So we have balanced the oxygen. Now, next step is you have the rules with you. Next step is balance hydrogen by adding H plus. So check H plus on this side. How many hydrogens? Check hydrogen on this side. 10 hydrogen on this side, 6 hydrogen. The difference is 4. So I'm going to add 4H plus on this side, right? So hydrogens are done for the first half equation. Let's see hydrogen for the second half equation. Second half equation, this one. There are 4 on this side, 0 on this side. So add 4H plus on the left side. Very good, Dhruv, Shrihan. Very good. Okay. Next step. Next step is balance charges. You remember? Balance charges by adding electrons. You can see in the rules. Okay, so how much charge here? So I want answer from all of you. How much charge here? What should I write here? Is there any charge here? 0, right? How much is here? This is 0. Yeah, plus 4. So how many electrons should I add on which side? How many electrons should I add on which side? You are going to add 4 electrons on the right side. To neutralize this plus 4, plus 4, now this is minus 4 is 0, 0 equal to 0. So remember this, electrons are always added on the side which has more positive charge because electrons will make it less positive then. Electrons are added on the side which has more positive charge. This is a like a kind of trick which you can use. Otherwise you can think, but in the exams I have seen children they get confused and they start struggling, where should I add electron? Then try to recall this statement. I should add electrons on the side which has more positive charge, right? Now do the same thing here. What's the charge on this side? Plus 4 minus 1. What's the charge on this side? 0. So this is how much? Plus 3. Now tell me, where should I add electrons? Yes, add 3 electrons on the left side, that the one which is more positively charged. Whatever is the difference in charge, in the positive charge, add that much number of electrons, right? Okay, so we are done with the balancing of the charges and with the balancing of the hydrogen, oxygen, arsenic, nitrogen, everything is balanced. So I'm writing it neatly again. This is 4 electrons here. This is 3 electrons here. Which one is oxidation? Let's say this is equation 1. This is equation 2. Which one is oxidation? Which one is reduction? Mhm. Oxidation is loss of electrons. Electrons should be on the product side. Reduction is gain of electrons. So electrons should be on the reactant side. So Dhruv and Saranya is saying that first is oxidation. Sanjana, you're not answering, dear? Yes, okay. Why you are saying first one reduction, Shrihan? You said the same thing last time. I corrected you at that time also. So you're again saying the same thing. And the second equation is reduction because electrons are on the reactant side. So do this correction, Shrihan. Okay, now step number 3, rule number 3, balance the half reaction. Now these are balanced half equation. They are balanced in terms of atoms and they are balanced in terms of charges. Now you are ready to add them together. But before that, we have to equalize the number of electrons. One is losing 4, but other one is asking 3. So how to make them equal? Look up for some common multiple. The common multiple is 12, right? So multiply the above equation by 3 and multiply the below equation by 4, right? So when you multiply the above equation by 3, it is 10 H2O plus 3 AS2O3 giving you 6 H3 ASO4 plus 12 H plus 12 electrons, right? 4 times 3. So this is equation 1 now. And equation 2 is, you're multiplying it by 4. 16 H plus 4 NO3 minus 12 electrons 4 NO 8 H2O. Oh, it's 15. Yeah, sorry. Dhruv, thank you very much. It's 5 times 3. There is a very popular equation. In that equation, we are multiplying by 2. So somehow that number is coming in my mind. It's 15. You're right. Okay. Now you're ready. Rest all is okay. Now we are ready to add them. When you add them, you have to see what are the things which are on both the sides, like 15 H2O and 8 H2O. Cancel. 15 H2O will become 7 H2O. Agreed? 16 H plus 12 H plus. Cancelled. 16 H plus will become 4 H plus. Right? 12 electrons cancelled. So what is the balanced equation? 7 H2O plus 4H plus 3 AS2O3. Those who are not participating in answering the question here, I tell you that it's very difficult to focus without participation. I'm sure that you will be getting distracted what is happening inside the house. But if you start participating, then your distraction will be less. That is the reason I'm asking all of you, whether you are slow, fast, making notes. Notes are already there on the website. So I'm already posted the notes over there. You can download them. So my request is participate here in answering the questions. That is what in the exam questions will be there. And you have to answer those questions. To have maximum attention in the class, what I'm teaching, the participation is needed. Those who are not participating, their attention is very less. They are diverted by what people are doing inside the house. Or maybe they are talking to them. Maybe parents are, some people around you are talking to you. Okay. So is this equation balanced? That's the next question. Check. Check here. How much? This is 0. 7 times 0 plus 4 times plus 1 plus 3 times 0, this is 0, plus 4 times minus 1. So what's the total charge on this side? Plus 4 minus 4, 0. What's the total charge on this side? 0. So this is your completely balanced equation without any error. If you get error here, if let's say your charges are not same, so many times when I'm balancing, I get error here, then go back and check your steps, all the steps from starting. Just check the steps where I did the error and correct it, and you will get the right equation. And this solution is acidic. You can make it basic also by adding 4OH minus on both the sides, right? Add 4OH minus on both the side and the solution will become basic. Okay, so do we have time for next method? No, we don't have time for the next method, but I would like to show you the important steps of the next method. It's called as oxidation number method. So you can try on your own also before coming in the next class. So I'm going to give you, you can take with the snipping tool, you can take the picture of this whiteboard, right? Or I can help you. But before leaving this class, I would like to discuss one more question, one more concept. This is redox number method, oxidation number method. You can take the steps with you. It's there on the website also. Okay, on the website, I think I have to upload the notes of Unit 4. That I'll do today, definitely. Before we move out of this class, let's do one more important reaction. Check this one. These reactions are called as disproportionation reaction. Here, what is happening? Check the oxidation number of chlorine here. What's the oxidation number? 0. What's the oxidation number of chlorine here? You can assume it as X, right? X, then plus minus 2 is minus 1. So what is X? Plus 1. And what is here? Minus 1. Okay, so what is happening? Is there any change in oxidation number of oxygen and hydrogen? No. Oxygen is minus 2, hydrogen is plus 1. So check here. Check the meaning of this disproportionation reaction. Here the chlorine gas is undergoing oxidation. This is oxidation. And the chlorine gas is also undergoing reduction. So the same molecule, same compound is undergoing, same compound is Cl2 gas, which is undergoing oxidation as well as reduction. These kind of reactions are called as disproportionation reaction. And you know, children, you know this reaction from your daily life. We know this reaction from our daily life. You know that when you go in the swimming pool, they say that we have added this bleaching powder, the chlorine gas. So what is that bleaching powder? It's just the chlorine gas in the presence of some strong base like NaOH, which gives you this hypochlorite. You check the polyatomic ion list, you already know this ion. This is hypochlorite. This is the one which acts like a bleach, disinfectant. You must have heard about that water is chlorinated. Chlorinated water. Chlorinated water means Cl2 with OH minus is added in the swimming pool water, which is going to give you this hypochlorite, which acts like a disinfectant. right? Okay, children. So in the next class, I will start next unit. But before that, we'll practice few more questions on this method. So this will not take much time, maybe 30 minutes. That's it. And after that, we'll start unit 5. But tomorrow there is no class. So happy New Year, children. And those who have questions, they can stay back in the class.